Good morning, ma'am.
Good morning. So let's start today's session. Today we are going to continue our discussion related to K nearest neighbor algorithm. So let's have a recap whatever we discussed about KNN algorithm in the last session. So KNN algorithm comes under supervised learning. So obviously in this supervised learning algorithm we are having training phase and prediction phase or test phase. So in training phase what we do is we simply store training examples. As I stated earlier, this KNN algorithm is instance based learning algorithm. So in instance based learning algorithm, in training phase, simply we are storing the training examples. We are not at all computing anything in training phase. In test phase, what we do is we present a query instance denoted as the query, right? Depending on the value of k that we have selected, we are finding out k training examples. Those are closest to our test sample xq. So let us assume that k training examples, those are closest to xq, are denoted as x1 y1, x2 y2, so on up to xk yk. So these are k samples, those are closest to xq. If the problem is classification problem, then what we do next is we predict the most frequent class from yi's. So after finding out k training examples, we are having kyi values for these k samples. So based on these kyi values, if the problem is classification, then we predict the most frequent class from these YIs. And if the problem is regression problem, then we predict the mean or average of the identified YIs. So this is a simple KNN algorithm. But the important point that we had discussed is how to find out which training examples are closest to XQ or the query instance. So to find out the closest samples, we need to find out the distance between the test sample and every training example. And based on those distances, it is possible for us to find out which training examples are closest. So, we have seen how to find out the distance between 2 points in n-dimensional space. So let us assume that we are having arbitrary instance xi with n features. And these n features are described like x1i, x2i up to xni, where this xni denotes the nth feature of instance I, right? Nth feature of instance I. Similarly, we are having another point, say xj, wherein we are having the feature vector denoted as x1j, x2j up to xnj. So now what we have is we are having two samples, xi and xj, and we want to find out the distance between these two samples. So to find out the distance between these two samples, we are making use of Euclidean distance. So Euclidean distance is defined as the square root of summation over r equal to 1 to n xri minus xrj bracket square. So what does this mean? What is this xri and xrj? See here, r varies from 1 to n. And what is n? N, the number of features that we have. So simply what we are going to do is, we are going to find out the squared difference between the respective features in both the instances, ith instance and jth instance, and the respective feature xr from both. So if r equal to 1, that means we are finding out x1i minus x1j square. Similarly, we are finding out x2i minus x2j square, so on up to the number of features n. And after finding out the square difference, we are going to sum up those square differences, and then we are finding out the square root of that. And this will provide us the Euclidean distance between 2 points in n-dimensional space. Right? So this Euclidean distance actually provides us the measure of similarity. So if the distance is smaller, that means these 2 points are closer to one another. Right? So let us try to write formally now this KNN algorithm for approximating discrete valued function. So discrete valued function means we are talking about the classification problem. Okay, so we are obviously having the training phase. So what we are going to do in training phase is, for each training example of the form xiyi, we are going to simply add the example to the list of training examples. So simply in training phase, we are storing the training examples. Right? So for every training example of the form xiyi, just adding into training example. In classification phase, what we do is, as I stated earlier, we are going to present the query instance xq that we want to classify. And what we do next is, we find out the k instances from this training set. Training examples is the training set. So we are going to find out k instances from training examples. Those are nearest to the query instance xq. Right? So what we are going to return now? So obviously we want to find out the yq that is associated with our query instance, right? So obviously we are going to return this yq based on some mathematical formula. So in fact, we know the process how we are going to find out this yq in case of classification, right? So we are finding out the most frequent class from k instances, those we have identified as the closest one, right? But let us try to mathematically formulate this formula. So what we are going to return is, we are going to return this yq. And what this yq would be? Yq would be R max V belongs to capital V, summation over I equal to 1 to k delta V comma yi, where this delta function, delta a comma b, is equal to 1 if a and b are same, and if a and b are different, then this delta a comma b is 0. What does this mean? See, we are going to return, we are going to predict this yq. And how we are going to predict this YQ? We are finding out for every class, we are finding out how many samples, how many instances from K instances are having that label. So for example, what is this V? Capital V denotes actually the set of all discrete class values or labels. Say for example, in the problem under consideration, we are having the class label as positive and negative. So how many classes? Two classes. Positive class and negative class. Right? So this capital V denotes these two discrete values. So let us assume that positive class is 1 and negative class is 0. Let us assume that. Okay. So this capital V will have two values. Which are those two values? 1 and 0. Class labels. Discrete class labels. Okay. So what we are going to do next is small v belongs to capital V. Hence for carry out some process. And what that process we are carrying out? Suppose, let us assume that value of K is equal to 5. Let us assume value of K is equal to 5. Right? So 5 times we are going to perform, or we are going to find out the value of this function delta. Right? And what that function delta is comparing actually V and Yi. Delta is comparing V and Yi. Right? And if both are same, then it will return 1. Otherwise, it will return 0. Now, let us assume that our K value is 5. Okay, and we have identified 5 instances from training examples. Those are nearest to XQ. Right? Now, let us assume that we have identified, say, X1, that is the first sample, and the class is, say, 1. So, Yi, this is Y1. Okay, X1, Y1. Y1 is 1 for this first instance. Then suppose this is second instance and Y2 is 0. Then suppose we are having third instance and Y value is 1, X4, Y value is, say, 1, and X5, Y value is 0. So these are our K instances. Those we have found out. Those are closest to our XQ. Now, if we want to compute this function, what will happen? See, we are going to pick every value from this set. So we are having two discrete labels. So we are picking up the first label, say 1. Right? Now, for this 1, what we are going to do is, we are having here the summation over I equal to 1 to 5 because K is equal to 5. And we are finding out this delta function. So what does this mean, delta function? We are finding out delta V is 1, okay, I is 1, so Y1. So what is Y1? 1. So delta 1, 1. Right? So if delta A comma B, if A and B are same, then this will return me the value 1. So delta 1 comma 1 will return 1. Right? So for K equal to 1, the delta value will be 1. This is my delta value. That is 1. Now, for I equal to 2. For I equal to 2. Right? My V value is 1. And what is my Y2? It is 0. Right? So delta 1, 0. So V and the label for this sample X2 is 0. Right? So there is a mismatch. So this delta function will provide me the value 0. Now I equal to 3. So for I equal to 3, my V value, obviously I am doing it for 1. So V value is 1, and what is my Yi? Yi is 1. Right? So for I equal to 3, I'll be getting 1. Similarly, for I equal to 4, I'll be getting 1, and for I equal to 5, I'll be getting 0. Now summation of all this. So summation is 3. Summation of all those deltas is 3. What does this mean? This means that out of these 5 instances, those we have identified, 3 instances are with class 1. Right? Similarly, we are going to find out this summation for V equal to 0, that is other class label. So obviously, what will happen? How many samples out of these 5? How many samples are from this class 0? 2 samples. So obviously, this summation 3 would be for V equal to 1. And for V equal to 0, we are having this, that is 0. So out of these 5, 3 belong to class 1 and 2 belong to class 0. Right? Now, we have computed these values. For V equal to 0, this summation is 2. So 2 samples belong to class 0 and 3 samples belong to class 3. So now we are making use of this argmax. So what this argmax function will do? This will return the class label. This will return the class label for which the computed sum is maximum. So for class label 1, the sum is 3, and for class label 0, the sum is 2. So for which class label the sum is maximum? For class label 1, the sum is maximum, that is 3, which is greater than 2, and that is why this YQ gets assigned the class label, that is 1. Right? And this is how we are predicting the class of this query instance XQ as 1 in this scenario. This YQ is actually the most common value of Yi among K nearest training examples. I hope you must have understood how actually to interpret this mathematical expression. If you have any doubts, please let me know. Yes.
Ma'am, here delta is the Euclidean distance, huh?
No. Delta is not a Euclidean distance. In the earlier slide, we have computed Euclidean distance. Correct? And based on that Euclidean distance, we have identified K instances. Those are closest.
Yes, ma'am. Yes, ma'am.
Right? And this is a different function that will help us to find out whether the label of the identified sample is V. And what is this V? V is one of the class labels that we have. In our case, we assume that we are having the samples with 2 class labels, 1 and 0. Even though this function looks this expression looks complicated, what actually we are trying to do in simple words, out of K instances, we are finding out the number of instances belonging to each class label. So if we are having 2 class labels 1 and 0, So out of 5, we are simply finding out of 5, how many belong to class 1 and how many belong to class 0. So in our case, 3 samples belong to class 1 and 2 samples belong to class 0 out of the 5 closest samples, because my K is 5. Right? So 3 samples are belonging to class 1 and 3 is greater than 2. So majority is class 1, and that is why we are predicting the YQ as class 1. Fine. So now let us see few examples, simple examples. So if my K value is 1, then our algorithm becomes 1NN. If K value is 1, then it becomes 1NN, right? Or 1 nearest neighbor. So given this query instance, suppose this is our training data set and this hollow circle is our query instance XQ, right? If it is 1NN, then what we are going to do is we are going to find out 1 nearest training example, right? So obviously if we look at this space, then it is possible to identify that this red sample is closest to XQ, right? And that is why if this sample is XQ and what we want to predict this YQ. So YQ will be predicted as the class label of this sample. If this sample is XP YP, right? This is 1NN. So this sample is XPYP and this sample is XQ, for which we want to predict YQ. So what we are going to do is we are going to find out the closest sample. So this is the closest sample that is denoted here as XPYP. So YQ is assigned the class YP, right? So this is 1NN. If we go for K equal to 3, then the problem becomes 3NN, 3 nearest neighbors. So given the query instance XQ, we are going to find out 3 samples from the training data set. Those are closest, right? Now once again, out of these 3, we are going to sum up the number of samples having class label say red and number of samples having class label say green. So here we find that 2 samples are having class label red and 1 sample is having class label green. So which is the majority class? Obviously 2. That is the red class, and that is why YQ for this sample will be predicted as red. So this will be predicted as the red sample, right? Because majority of the closest samples are red samples. So this will be predicted as belonging to this red class, not this green class, right? So simply what we are doing is, out of these K samples, we are asking these nearest K samples to vote, right? So this is voting for red, this is voting for red, and this is voting for green. So 2 votes to red and 1 vote to green. So obviously 2 votes means this is the winner. So red class is the winner, and that is why prediction is red class. So simple it is, right? We typically use the K value that is greater than 1 because it provides us the smoothing effect. What we mean by that? Typically, the value of K greater than 1 is good when there is noise in the class labels. What does this mean, noise in the class labels? Sometimes it may happen that few of the samples in the are incorrectly labeled. Meaning, if the sample in the training data set is red sample, it is labeled mistakenly as green. So that is called as a noisy label, right? So if we are having such kinds of noisy samples in our data set, instead of relying with k equal to 1, we should select some value of k that is greater than 1. Right? We are going to discuss the ways how to select this k value. But this is one simple assumption that if my data set is having some noisy samples, then it is always better to go with k. If my is our x. Now, if I use 1 NN, then what will happen? I'll get the class for XQ as positive because this is the sample which is closest. And as I am using 1 NN, whatever is the class of this sample, that class will be assigned to my query instance, right? So XQ will be predicted as positive if it is 1 NN. But if it is 5 NN, what will happen? If it is 5 NN, then 5 nearest samples will be identified. So for this XQ, we are having 1, 2, 3, 4 and 5. These 5 samples are closest, right? And if we apply our logic to find out the majority samples belonging to which class, then obviously 3 samples belong to negative class and these 2 samples belong to positive class. So XQ will be predicted as negative if k equal to 5. So please remember here, it may happen that depending upon the value of k, our prediction will be different. The KNN algorithm for approximating continuous valued function. So continuous valued function meaning it is a problem of regression. So if we are trying to look at the problem of regression, what we are going to do is we are going to calculate the mean value of the k nearest training examples, right? So YQ is assigned the value. See here what we have done, summation over I equal to 1 to k yi divided by k. So k samples we are having, those are closest. So whatever are the yi is values, we are summing up those yi values because yi here is a continuous value and not the discrete one, because it is regression problem. So we are summing up all those yi's and we are dividing it by k so that we can have the average. So this is giving us mean or average, and that mean is assigned to YQ, that is my prediction, right? So simply, if the problem is regression problem, then we are finding out the average of the yi is, and that will be my predicted value for YQ. Okay, now let us solve one problem. Everybody, right now we are going to solve this problem. So everybody should have pen and paper and we are going to solve this problem. You may have similar kinds of problems in your exam. So suppose you have given the data as shown, where x and y are 2 input variables and class is the dependent variable. So this is my feature 1 and this is my feature 2, suppose, and this is my class label y. right? So here, how many instances are given in my training data set? 1, 2, 3, 4, 5, 6, 7 and 8. 8 instances are provided. So this is my feature vector for first sample. What is feature vector? -1, 1. For second instance, 0, 1 is the feature vector and so on. Right? So this is how the training data set is provided, and the class label is also provided. So negative class and positive class. Right? And what has been, suppose you want to predict the class of new data point x equal to 1 and y equal to 1 using Euclidean distance in 3NN. So what has been asked for? It is asked to make use of 3 nearest neighbor algorithm, 3NN. So k value is 3, right? And you are asked to predict the class for the data point given as 1, 1. Right? So the data point given is 1, 1 and you are supposed to find out the class for this data point 1, 1, whether it is positive class or whether it belongs to negative class. So how to solve this? Yes, we need to show all the computations. Those we are performing, right? So let us try to solve this. So this is the training data set. See, you are supposed to solve this systematically. So this is the training data set provided. So these are the features for all those instances. And how many instances we have? 8 instances in our training data set. Right? So every training data set, 2 features. So it is described by -1, 1. And the class for this sample is negative. Right? And my query instance xq is having the feature vector 1, 1. So for this xq, I want to predict yq. Right? And I need to make use of 3NN. Right? So what we need to do? We need to compute Euclidean distance between our xq, that is the query example, and each training example. So how many examples we have? 8 examples. So we need to compute the Euclidean distance between our test sample, that is, and each training example. Right? So what is our formula for Euclidean distance? The Euclidean distance is being computed as square root of summation over r equal to 1 to n x r I minus, here we are having all these are xi's, okay, and we are having the target example, that is x r q, and square of this. So this is the formula that we need to make use of. Here the value of n is equal to 2 because we are having 2 features describing each instance. Are you getting me? Yes? Are you getting me? Yes.
Yes, ma'am.
So now let us try to find this. So for xi, I equal to 1, right? So for the first example, what we want? We want to find out the distance between this -1, 1 and the query instance 1, 1. So how to compute this distance? D equal to square root of, right? Square root of R is 1. We are having two features. So R is 1. So x1i, right? So this is my x1, first feature of ith sample. Okay. So this is -1. Okay. -1 minus this xrq. So first feature of query sample. So first feature of query instance, that is 1. So -1 square plus the second feature of ith sample, that is 1 minus the second feature of xq, that is 1 square. So what this will give me? -1 minus 1 is -2 whole square. So it is 4. 4 plus 0, right? And square root of that. So this distance is equal to 2. So,
Ma'am,
yes.
I didn't understood that second term. 1 minus 1.
This is first feature from this xi. So -1. And first feature of xq. So minus first feature of xq is 1. So -1 whole square plus. There are two features, na? So we'll be having these two.
Okay. Yes,
So
yes, ma'am.
this is second feature 1, and this is second feature 1. So 1 minus 1 square. Right? So similarly, we need to compute all those distances. So what will happen here? 0 minus 1 square plus 1 minus 1 square. So it comes out to be 1, right? D equal to square root of 0 minus 1 square plus 2 minus 1 square. So it is 1 square means 1 plus, so 1 square 1. So square root of 2. So it comes out to be 1.4142. Then square root of 1 minus 1 square plus -1 minus 1 square. So 1 minus 1 is 0. This is 4. So it comes out to be 2. Now for this, D equal to square root of 1 minus 1 square plus 0 minus 1 square. So this is 0 and this is 1 square, so it would be 1. Okay. Now for this, D equal to square root of 1 minus 1 square plus 2 minus 1 square. So 0, 2 minus 1 is 1. So 1. Now for this, D equal to square root of 2 minus 1 square plus 2 minus 1 square. So 2 minus 1 is 1 square. So 1 plus 1, 2. So square root of 2. So once again it is 1.4142. And for this, 2 minus 1 square plus 3 minus 1 square. So 1 square is 1. 2 square is 4. So this is square root of 5. So what is square root of 5? It is 2 point something, 2.236. right? So we have computed the distances. Now, what next we would like to do? We want to find out 3, k equal to 3. So we want to find out 3 nearest samples based on this, right? 3 nearest. So what is the minimum distance that we have computed? 1. So we are having 3 samples here with distance equal to 1. So these 3 are closest, right? So we need to select this, this and this. These 3 are closest, right? And for all those 3 samples, those are closest, we need to find out the class. So obviously here all these 3 samples belong to positive class, right? And there is no sample out of these 3 belong to negative class. So obviously what we will predict? We will predict YQ as positive class. YQ as positive class. Got it? Yes? Any doubt? Have you understood how to identify this? Now please tell me, if I am making use of 5NN, then what would be the class? If I am making use of 7NN, then what would be the class? Yes, for 5NN, what would be the class? And for 7NN, what would be the class? Yes. For 3NN, we have identified for 3NN YQ equal to positive. For 5NN, what is my YQ? And for 7NN, what is my YQ? Yes. Anybody who can answer? We are having all these statistics with us. Yes. Anybody? For 5NN, what we need to do? We need to pick 5 closest samples. Correct, na? So these 3 are closest, and next closest sample might be this and this. So these are 5 closest samples, right? So out of these 5 now, 3 are having positive class and 2 are having negative class. So majority, 3 samples are having positive class. So once again, we are predicting YQ as positive for 5NN. What will happen for 7NN? We are having in fact 8 samples. So we are going to select next 2 samples, those are closest. So this also and this also for 7NN, right? So out of these 7 samples, those we have selected which are closest, how many samples are having positive class and how many having negative class? Out of these 7, 3 samples have positive class and 4 samples have negative class. 3 samples have positive class and 4 samples have negative class. So majority samples 4 are having negative class. So if we go for 7NN, then YQ is predicted as negative class. Got it?
Yes, ma'am.
Right? Any doubts so far?
No, ma'am.
Fine. So you may have such kinds of problems in your exam that you are supposed to solve. Okay, so I hope you must have understood how to deal with such problems. So let's stop today. Thank you.